All right, so let's explore a little bit more about trig ratios, okay? So let's say I wanted to set up, we have this right triangle, ACB, and let's say I want to set up the sine of A, okay? And so we're going to label these. So typically when the vertices or the angles are the uppercase letter, the sides across from them are actually the lowercase. So we're going to use, here's big A. So across from big A is little a, across from big B is little b, and across from C is little c, all right? And so if we set up the trig ratios for the sine of A, well, sine of A is, remember, opposite over hypotenuse, because it's so. So the opposite of A, we go over here, and the opposite is A. And the hypotenuse is always across from the right angle. That never changes, so I can go ahead and label that. All right, so we got C. Okay, and so that would be our ratio. Well, let's say I want to set up, how about the cosine of B? So remember, cosine is ca, so adjacent over hypotenuse equals cosine. So if I go to B, here's B. So if I want to go to the adjacent, so adjacent means right next to, so it's going to be little a, over the hypotenuse, well, the hypotenuse is always C. And so what I notice is that I can have two different trig ratios. They're of two different angles, but the answers are the same fraction, okay, or the same ratio of sides. And so do you think that's going to be a coincidence? Well, no, because basically if you take one angle, its opposite side is the adjacent side of the other acute angle, okay? And the hypotenuse is always going to be the same. So if we're talking about hypotenuse, the opposite and the adjacent are going to be vice versa. So what else will we know is true? Well, what if we did that? What if we did the sine of B? Is that going to be the same as the cosine of A? What do you think? Well, let's try it. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So if we want sine of B, so here's B. So I go opposite, which is B, over hypotenuse, which is C. And here's angle A. So adjacent is B, over hypotenuse is C, and they are true. So yeah. So the way it works is we can come up with a rule. And it says that the sine of an angle is equal to the cosine of its complement. And so why did they use complement? Remember, complement means two angles that add up to 90. And so first of all, if we have trig ratios, that's only in right triangles, okay? The right angle is always 90 degrees. We know all three angles have to add up to 180, so that leaves 90 for the sum, okay? And so that's why they say complement. And so I always think of the two acute angles, the sine of one is going to equal the cosine of the other, okay? And that's always going to be true. And so what happens is we can use this relationship to kind of solve problems. So let's look at example number 1. So they say it's a scalene, it's a right triangle, ABC, and they tell us that angle C is equal to 90. Remember, trig ratios are only true in right triangles. So even if they don't say that, it's going to be implied somewhere, okay? And so what I know, these are my two acute angles. So which of these is always true? And so I'm going to see if we can remember that without that rule up there. And so I think, oh, well, did the sine equal the sine? Did the cosine equal the cosine? And I'm like, no, I remember they weren't the same. But I know they were opposite words, but we got to pay attention to the letters. So does the sine of A and C, or did the sine of A and B equal each other? And so then I remember, oh yeah, we can't take trig ratios of the right angle, so C is never going to be involved. So it has to be A. Number 4, sine of A is equal to the cosine of B. All right, so remember, it's the two acute angles. The sine of one equals the cosine of the other. And it doesn't matter which one, because you're going to use both of them. All right, so we're going to use that idea. And so it says, example 2, if the cosine of 72 equals the sine of x, find the number of degrees in the measure of x. And so it's this idea. So it's saying, oh, hey, what if we had a triangle, and I know 72 is one of my acute angles. X is the other, because I see this sine and cosine, and I see the equal. And so I'm like, oh yeah, the sine and cosine, they got to be the opposite angles. And so what we know is that 72 plus some number has to equal 90. Okay, and so you can think about this, or you can set up an equation. It really just depends. So if we subtract 72, we get x equals 18. And so that's what we're looking for. The other angle had to be 18 degrees. Yeah, it really is true. All right, example number 3 looks super tricky because basically what they did is they took one right triangle and then they put it inside another right triangle and put that one inside another right triangle. And so they just can put them all together. And so they say this is 30 degrees. And so what you know is that that top angle of all 3 triangles is still 30, okay? And so it does say that AG is parallel to BF is parallel to CE. And so we know all of these are going to be similar right triangles, okay? So they want to know all of the expressions that are equal to the cosine of DFB. So first, let's find out what angle they're talking about. So go in order. So here's D to F to B. So they're talking about this angle, okay? So we need to know, which is this angle, which of these 3 choices, if I've got the cosine of DFB, which of those is it going to be equal to? So this is a couple of ideas in play. So remember, when we have similar triangles, the angle values are the same. So like that top angle is all 30, and I know these bottom angles are all going to be the same. So the cosine of that is equal to the cosine of that and the cosine of this angle. Okay, so that's the first thing that's true. So when I say cosine of G, we know that's true. So I'm going to circle it. Well, there isn't another cosine, so I'm not looking at these 3 angles anymore, but they could have said cosine of DEC, and that would have also been true. So now, that was from similar figures. Now we're going to use the idea here where these 2 acute angles, the cosine of one equals the sine of the other. Well, if that's all the bottom angle, so this was the cosine of the bottom on all of these, then that has to be equal to the sine of the top. And so the sine of the top is the same in all of those. And so we just have to know how to name it. So if we look at DEC from their choice, here's DEC, that's this angle, and we wanted cosine. So we're going to say, oh no, if that was cosine, it would have been true. But that one's false. We know it's the sine of D is that top angle, and that is the same in both of them. Okay? So we need to talk about the angles are all the same in similar triangles, but the complementary sine and cosine are of the 2 different angles. Okay? All right, example number 4. This is a little tricky. I saw this on a released park exam, a state exam for the course, and so I thought this is kind of interesting. Let's just do this one together. So they give us right triangle ABC, and they tell us that these 2 angles are not equal to each other. And I would assume that anyway, so that's all right. That's what that means. So it says, let the sine of B equal R, and let the cosine of B equals S. What is the sine of C minus the cosine of C? And it's like, oh my goodness, what are they talking about? So, well, what I know is that we've got sine of B, so sine is opposite over hypotenuse, and the cosine of B is adjacent over hypotenuse. Okay, and we know that these have to add up to 90, the angles do, but we want to talk about the cosine and sine of the C angle. So if I know that the sine of b is r, so remember, the sine of b, that's going to be equal to the cosine of c, right? And what I know is that these two numbers have to add up to 90. So add up to 90, right? Stay with me. I'm going to help think you through this problem. So I know that the sine of b is r. So in this whole place, I'm going to put r, okay? And I know these have to add up to 90. So we've got r plus the cosine of c equals 90. Does that make sense? Okay. But I only really care about the cosine of c, so I'm going to subtract r. So I know the cosine of c equals 90 minus r. You with me so far? This is kind of tricky. So then let's do the same idea. What about the cosine of b? So I know, let's write it over here. The cosine of b has to be equal to the sine of c. And once again, I know that these have to add up to 90. And so I'll even write it a different way. I could write the cosine of b plus the sine of c has to equal 90. And it's really the b and c. So we know the cosine of b is s. So subtract s. So sine of c equals 90 minus s. Does that make sense? So now, I'm going to get some more room here. There we go. Perfect. That's all I need. So now if I want, let's do black, the sine of c minus the cosine of c. I can use these for substitution. So here's the sine of c, so 90 minus s. And the cosine of c, because we're subtracting, we do need to use a parenthesis. So we subtract both terms. And remember, a negative, that's like a -1 that we're going to distribute. So then I get 90 minus s. -1 times 90, and -1 times -r is positive r. So then we can combine like terms. 90 minus 90 cancels out. And so I'm left with -s plus r. Well, we don't have to write it that way. We can change the order. I could put the r first and the -s second. So r minus s. Okay. That was a tricky one. That's why I wanted to do it together. Am I going to have something that tricky on your quiz or homework? Probably not, but I think it's fun to see. All right, example 5. It's going to kind of be similar, but maybe a little easier. So it says find the value of x. So remember, what we know is that these two inside angles have to add up to 90. So I know that 2x minus 1 plus 3x plus 6, that all together has to be 90 degrees. So we're going to combine like terms. 2x plus 3x is 5x. -1 plus 6 is 5. We don't do the opposite because we're not moving them to the other side of the equals. We'll go ahead and subtract 5. So 5x equals 85, and those are being multiplied, so now we can divide. So x equals 1, 7. And that's what we're looking for. Okay. Now, this problem you can do two different ways. Same thing. The cosine of one angle equals the sine of 55. I know these two together have to add up, oops, minus 25, also have to add up to 90. Or we could find out, well, if I know that that's 90 total, I can take off 55, which gives me 35. And so I now know that 2x minus 25 has to equal 35, and we could solve that. Both of these are the same ideas, they're just different equations, okay? So let's just say I saw the one on the left. I would get 2x, we're going to add those, what, negative 25 plus 55 is, I don't know, what do I get? 30? Wait a second. What did I just miss? That plus that have to equal 90. Did I take this off wrong? No. 8, 1, 5, 35. Oh yeah, right there. Okay. So I get plus, what is that? 25. 55 minus 25 is 30. Equals 90. So subtract 30. I get 2x equals 60. Those are being multiplied, so divide by 2, and x equals 30, which is what they wanted. And not 30 degrees, sorry, just 30. If I found the math, what it was supposed to equal, I would add 25. So 2x equals 60, and then divide by 2. So x equals 30. The degrees is already on the outside. That's why I don't need it. So either way, it's the same idea. Okay? But remember, the two sine and cosine of the two acute angles, they're complementary. They add up to 90.